Our objective here is to check to see if these two functions, which look very similar, are inverses of each other. I've got doubling, and I've got halving, I've got adding, I've got subtracting. This looks like a pretty good candidate. So let's do the test. In order to verify if two functions are inverses of each other, I need to show that the composition of the two functions simply yields that variable. So let's check. F of g of x is the same as taking whatever the g function is and plugging it into the f function. So f of, now let's plug in g, 1/2 x minus 4. So that's going to replace my variable in the f function. Where I see this x, I'm going to write this expression out. So that composition would then be 2 times my input, 1/2 x minus 4 plus 4. Now let's simplify my expression. I distribute, combine like terms, and I'm done. Cannot go any further with that. And unfortunately, I did not get x. My conclusion then is that f of x and g of x are not inverses. If they had been, I would have gotten x as an answer. If there's any doubt, before I go too much further, we can always double check our work by actually plugging in some real values and see what happens. So for example, let's use the value of 1. F of 1 would be 2 times 1 plus 4. 2 times 1 is 2 plus 4 is 6. If these were indeed inverses of each other, then g of 6 should yield an answer of 1. Let's find out. Let's go plug that in. So 1/2 times 6 minus 4 gives me 1/2 times 6 is 3. Minus 4 is negative 1. 1 went in, it got turned into a 6. 6 goes into the other function and gets turned into a negative 1. They don't match. Therefore, g cannot be the inverse. While it's tempting to use the real number test, be very careful not to do it as your primary source of proof, because it is possible to find the rare value that does check out for both. Since we verified that it doesn't work in the more general sense, I can say with confidence that any number I use is not going to be sufficient. It's just not going to work. That is the better proof over here. This is simply an illustration. So remember, to verify if something is an inverse, you need to do the composition, f of g of x, and if that checks, repeat it by doing it in reverse, g of f of x. And in both cases, you should get the original variable as your final answer.